Okay, we're going to talk about U-substitution. So U-substitution is another way to find an antiderivative. So remember, when you're finding antiderivatives, we don't have things like the product rule and the quotient rule. And so when you see functions which look like they have products and quotients in them, you should be thinking, I either need to simplify or I can use some U-substitution. So the way U-substitution works is it's sort of the opposite of the chain rule. So remember when we did the chain rule, we said derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. So when we do U-substitution, we want to look for something that looks like that, an outside function, an inside function, and the derivative of that inside function all mushed together. So that when we take its antiderivative, we end up with like a composition. So when we're doing U-substitution, here are our procedures. We're going to look for a piece of the function whose derivative is also included in the function. If you can't find it right away, then you think about things that are in the denominator are often good candidates, or things that are being raised to powers or underneath the square root or inside a sine or a cosine, those kinds of things. So we're going to set u equal to that piece of the function, and we're going to take the derivative with respect to whatever variable we had. And then we'll use our u and du to replace and then integrate. And it should be a lot easier to do the integral when we do that. So let's take a look at this first example. And this first example says the integral of 3x minus 4 to the 5th dx. And what we kind of notice here is that my inside function is this 3x minus 4. That raising to the 5th is something I can deal with. So what I'm going to do is I'm going to set u to be 3x minus 4. Now I need to know what the derivative of that is to see if it's included in my function. So I take the derivative of this with respect to x. So derivative of 3x is 3. So derivative with respect to x. Derivative of negative 4 is 0. So I just get 3. So what I'm going to have is du is 3 dx. So notice here in my function, I have this dx, but I don't have the 3. So if I want to put a 3 in here, then I would need to put a 1/3 on the outside. Alternately, you can solve for dx because that's what I have over there. So divide both sides by 3. So dx is du over 3. So I'm going to rewrite this integral as u to the 5th times du over 3. Now I can pull that constant in the front when I'm integrating. So 1/3 u to the 5th du. And now this integral is just the power rule. Add 1 to the power, divide by the new power. So 1/3 u to the 6th divided by 6 plus c. And the last thing you want to do is you want to be extra careful because your integral started with x's, so you want to end with x's. So I'm going to replace this u with that 3x minus 4. So I'm going to end up with 1/3 times 3x minus 4 to the 6th divided by 6 plus c. If you want to, you can simplify. You can combine this 1/3 and this 1/6 and get 1 over 18 times 3x minus 4 to the 6th plus c. Okay, so let's try again. This one looks really similar to the one we just did, right? And I'm going to pick that inside stuff again to be my u. So I'm going to say u is x cubed plus 4. And then remember that what I do is I take the derivative of that. Du dx is x cubed is 3x squared plus 0. If you notice, I have 3x squared inside of here. So du is 3x squared dx. So all of this 3x squared dx is going to be part of my du. So when I rewrite this integral, I have this u to the 5th, and then all that purple stuff, that 3x squared dx, is my du. And I'm just going to integrate just like I did. Add 1 to the power, divide by the new power. And then at the very end, my last step is to substitute back in. So sometimes you won't have to do any extra work like we did in the last problem. X to the 3rd plus 4 to the 6th divided by 6 plus c. Okay, let's try again. So in this one, I'm going to pick my u to be, remember we said things if they have raised to a power or inside a square root. So I'm going to pick my u to be 4x minus 5. Du over dx is going to be 4. So du is 4 dx. I don't have a 4 in here, So I just have that dx, so I have to solve like I did in that previous example. So divide by 4, and I get dx is du over 4. Okay, so let's rewrite this guy. I still have that square root. He was not part of any of this u. So square root of u times du over 4. I'm going to rewrite this before I take the antiderivative. So put a 1/4 in the front. Square root of u is like u to the 1/2 du. Okay, add 1 to the power. 1/2 plus 1 makes 3/2. Divide by the new power, divided by 3/2, plus c. So we can do this in our calculator, 1/4. This is, you can flip this over, multiply by 2/3. So this is going to be 1/6. You can figure out that fraction in your calculator. Again, I started with x's, so I want x's in my answer. So I need to replace this u with that substitution I made. So this is 4x minus 5 to the 3/2 plus c. Remember, this plus c comes because when we're doing these kinds of integrals, it's a family of answers. It's not just one single answer. I could add any constant to here, and when I take the derivative, it's still going to be the same. Okay, so that 1/6, remember, came from 1/4 times 1 over 3/2. Okay, another example. So this one says the square root of x minus 1 squared over square root of x. So again, I'm going to always try to pick the stuff that's inside powers and see if it works out. So in this case, I'm going to pick u to be square root of x minus 1. I know that the derivative of square root of x is 1 over 2 square roots of x. You can rewrite this as x to the 1/2. Bring the power in front, 1/2 x to the negative 1/2. Put it in the denominator, 1 over 2 square root of x. And so what I notice is that I have a lot of the stuff I need in here already. So du is 1 over 2 square root of x dx. What I notice is that I have all of this stuff in there already. What I'm missing is that 2. So I'm going to put that 2 on the other side, okay? So times 2 times 2. So here, for all this purple stuff, I'm going to rewrite it as u squared times 2 du, or 2u squared du. Okay, integrate, add 1 to the power, divide by the new power, and then substitute back in. Remember, you started with x's, so you want to end with x's. So I'm going to substitute this guy back in, and I get 2/3 square root of x minus 1 to the 3rd plus c. So here's some more examples, and the best way to get good at U-substitution is just to do a bunch of examples. So on this, you know, we're going to have 8 examples, and in your videos there's more than that. So just do a bunch of examples. Okay, in this one, what I notice is that I have this cosine up here in the exponent, and I don't really know how to do antiderivatives of e to anything besides just x. So I'm going to make that my u. So I'm going to pick u to be cosine x. The derivative of cosine is negative sine. So I need a negative in here. So du is negative sine x dx. Notice I have the sine and the dx. I just need a negative in there. So I'm going to stick that negative in. So negative e to the u du. Okay, antiderivative of e to the u is just e to the u plus c. Again, I started with x's, so I want to end with x's. So here for u, I'm going to make that substitution. So I have negative e to the cosine x plus c. So anytime you want, you can stick in numbers. So notice on this example, I stuck in that -1. On that last example, I stuck in the 2, right? So anytime you want, you can stick in numbers. What you can't stick in are functions or things with x. Okay, this one says cosine of 2x plus 1. I'm going to pick it to be the inside stuff. Remember, this is the opposite of the chain rule, so I'm always going to pick my u's to be the inside stuff. So u is going to be 2x plus 1. Derivative of that is 2. So du is 2 dx. So notice again, I'm missing that 2, right? I have the dx. The cosine is my outside function, so he's going to stay. So I'm going to go ahead and stick in that 2. Cosine u du. Okay, antiderivative of cosine is sine. I can't stick in a 2. I have to stick in a 1/2. I'm going to stick in a 2 inside. I'm going to stick in a 2 here, which means I need a 1/2 in the front. Sorry. If you put a number on the inside, you have to put its opposite on the outside. Okay, antiderivative of cosine is sine. And then I'm going to substitute back in my u here. So 1/2 sine 2x plus 1 plus c. Okay, 2 more examples. Okay, let's try this next example. Cotangent of 3x dx. What I'm going to do before I pick my u and du, because I don't really know the antiderivative of cotangent. So what I'm going to do is I'm going to rewrite this as cosine over sine. And then I'm going to pick my u to be that denominator, that sine. Okay, so I'm going to pick u to be sine 3x. The derivative of sine is cosine times 3, because I need the derivative of that inside function. Okay, so du is 3 cosine 3x dx. I have almost exactly what I need over here. I have cosine 3x dx, so I'm missing that 3. Remember, if I put a 3 here, I need to put a 1/3 in the front. So I can rewrite this as 1/3 1 over u du. Again, you can do the solving stuff if you'd rather. Okay, the integral of 1 over u is natural log absolute value of u. I started with x's, so I want to end with x's. So I'm going to replace this u with sine 3x. So I have 1/3 natural log absolute value sine 3x plus c. Okay, let's try again. So in this example, I'm going to pick that denominator to be my u again. U is 4 minus e to the x. The derivative of that is negative e to the x. So du is negative e to the x dx. Notice I have the e to the x dx up here. I'm just missing that negative. If I put a negative in here, I have to put a negative in the front. So I have negative integral 1 over u du. Okay, the integral of 1 over u is natural log plus c. Substitute in, because you started with x's, so you want to end with x's. So substitute in for u, and we get negative natural log 4 minus e to the x plus c.